In this video, I'm going to solve this question. Suppose that the time between successive occurrences of an event follows an exponential distribution with mean 1 by lambda minutes. Assume that an event occurs. What will be the probability that more than 6 minutes elapses before the occurrence of the next event? So first of all, let's understand what's the information given in the question. So suppose that the time between successive occurrences of an event follows an exponential distribution. So the time between successive occurrences of an event, I'm going to call it random variable x. Okay. So this is how I'm defining x. So basically we are given that x follows an exponential distribution. Okay. And the mean of x, that means the expected value of x, is equal to 1 divided by lambda. Right? Now assume that an event occurs. We have to find the probability that more than 6 minutes elapses before the occurrence of the next event. Now take a look at the definition of the x. X is the time between successive occurrences of an event. So if this is one event and if this is one event, the time between these is your x. Okay, so the time between successive occurrences of an event is your x. That's how you can visualize it. So assume that an event occurs. That means let's say this event has happened. They are asking you what will be the probability that more than 6 minutes elapses before the occurrence of the next event. That means over here the time spent should be greater than 6 minutes, right? So x should be greater than 6, and this is the probability that they are asking you, that what's the probability that x is going to be greater than 6, right? So that's what we have to find given this pieces of information. So let's do this step by step. So first of all, I've written the definition over here. A random variable x is said to have an exponential distribution with this parameter. If the PDF of x is this, so this is the probability density function of x. This is the mean of x that we are already given in the question. In the question, they have not given us any information related to the variance of x. This is some additional piece of information that I wrote from my side, but this will not be required. So you can ignore this for now. Okay. So because we know that x follows an exponential distribution, we know that this is going to be the PDF of an exponential distribution, and this is the mean that we are given in the question. Our purpose is to figure out the probability that x is greater than 6. Okay, now x is greater than 6 is going to fall in this region, right? Over here, x greater than equal to 0. So the part of PDF that is going to be valid for us is this, lambda e raised to the power minus lambda x. Okay, so that means to find the probability that x is greater than 6, we have to integrate f of x from 6 to infinity. And the part of f of x that we are going to use is this one, right? So let's do this integration now. So as I've written over here, probability that x is greater than 6 is going to be this. So this is the part of f of x that we are integrating, because this corresponds to the range in which our values of x are falling. So now if you integrate this, in this particular expression, lambda is a constant. So you can take lambda out. Okay. So if you take lambda out, that means the integration will be applied on this. Okay. And the integration of e raised to the power minus lambda x is actually e raised to the power minus lambda x divided by minus lambda. So this is the integration of this term. And then we have lambda over here. So this lambda over here. And now we just have to put these values. Okay, so this is what I have written over here. You put the values, first you put the value infinity in place of x, and then you put the value 6 in place of x. You solve this, and you will have to do 2 or 3 steps to simplify this, and in the end you will see that the probability that x is greater than 6, this comes out to be this. Okay, so this is your final answer.